At Rescue Education, we have the best explanation every time. I'm Dr. B, and I'm going to help you easily and rapidly learn organic chemistry. If you like the video, you'll love my book. Learn more about it at rescueedu.com or hear more about it at the end of the video. The second semester book comes out in fall 2020. Let's talk about the nomenclature of alkyl halides, alcohols, and ethers. Quickly review video 3.1 if you don't remember the basic IUPAC rules. First, let's look at the IUPAC nomenclature of alkyl halides. In IUPAC nomenclature, a halo group has very low priority. It is always a substituent. It never defines a parent. It is usually considered to be of identical priority to an alkyl group, and they compete directly for alphabetical order and numbering. In common nomenclature, very simple alkyl halides are named as alkyl substituents on the halide. Many of these historical names are usually or exclusively used. In IUPAC nomenclature, this simple molecule would have a methane parent with a chloro substituent. In common nomenclature, it would be a chloride with a methyl substituent attached. Notice the space between the two words. Pause and try these sample problems. Give systematic IUPAC names for all the molecules. Also, give common names for B and C. The parent of the first compound has 7 carbons and is a heptane. In this case, the parent can be viewed as being either horizontal or snaking from the top to the right. It has ethyl and fluoro substituents. Ethyl goes before fluoro in the name because it has alphabetical priority. For numbering purposes, these substituents are considered to be of identical priority. Numbering from left to right, you get 3, 5. And numbering from right to left, you also get 3, 5. The tie is broken by considering alphabetical priority. Ethyl beats fluoro, so ethyl gets 3 and fluoro gets 5. The second compound is called 2-chloropropane in systematic IUPAC nomenclature. In common nomenclature, it is called isopropyl chloride, which is what it's usually called. In systematic IUPAC nomenclature, the last molecule is bromomethylpropane. Bromo comes first because of alphabetical priority. The two numbering schemes are 1, 2 versus 2, 3. 1 beats 2 at the first number, so this is 1-bromo, 2-methylpropane. This molecule is usually called by its common name, isobutyl bromide. The IUPAC nomenclature of alcohols is very important. The longest chain containing the OH group is the parent chain. OH is called a hydroxyl group. It may not be the longest chain overall, but it must contain the hydroxyl. Change the E ending of the corresponding alkane to OL. The hydroxyl of alcohols has a higher priority than any group studied so far. It's higher than double bonds, triple bonds, halo, or alkyl groups. When numbering, only worry about giving the hydroxyl the lowest possible number. Then number other groups and unsaturations based on this. This makes numbering very easy. The number of the hydroxyl goes before the entire parent name. So, for instance, you would use the name 3-heptanol. If a molecule has both a hydroxyl and a double or triple bond, they are both incorporated into the parent name. Change the ending of the corresponding alkane from ane to enol or einol. The number for the hydroxyl always goes right before the ol. In old IUPAC, the number for the unsaturation goes before the entire parent name. In new IUPAC, the number goes directly before the ene or ein. The name 2-butene 1-ol would be correct in old IUPAC, and the name but-2-ene 1-ol would be correct in new. Most books still use old IUPAC, so we will too. In cyclic alcohols, the highest priority hydroxyl must get position 1. It is understood to be there and is not numbered. If there are double and triple bonds, their locations are then considered next. Finally, you would worry about numbering the lowest priority alkyl and halo groups. Pause and try these sample problems. Give the following molecules systematic IUPAC names. The parent of the first alcohol has 7 carbons. The longest chain actually has 8 carbons, but cannot be the parent because it does not contain the hydroxyl. The only consideration in numbering is to give the hydroxyl the lowest possible number, so we only need to number from right to left. The parent name is derived by changing the E of heptane to OL. Give the hydroxyl position 2. We also have chloro, methyl, and propyl substituents in alphabetical order. Leave spaces for their locations. Since hydroxyl is at position 2, this means the chloro must end up at 6, methyl at 5, and propyl at 3. The next molecule is an enol with a 6-carbon parent. Number from the right to give the hydroxyl the lowest possible number. We change the ane of hexane to enol. The hydroxyl is at position 2. And the double bond must be given position 4 based on this. There is also a methyl substituent. It's at position 5. In cyclic alcohols, the hydroxyl must get position 1 because it's highest priority over all. The 1 is understood and there is no need to write it. This molecule also has a double bond, so it's a cyclohexenol. Leave a space for the position of the double bond. There are also 2 methyl substituents. The question here is which direction to number in. Since double bonds have the next highest priority, we only worry about their numbering next. We number to the right to give the double bond the position 3, and finally, the lowest priority methyls get the 6-6 positions. The common names of simple alcohols are derived by putting the name of the alkyl group before the word alcohol. Notice the space. The names methyl alcohol, ethyl alcohol, isopropyl alcohol, and tert-butyl alcohol, or T-butyl alcohol for short, are often used. Alcohols with 2 hydroxyls are diols, and those with 3 hydroxyls are triols. Add the suffix diol or triol to the corresponding alkane name. In systematic IUPAC nomenclature, the first molecule is 1,2-ethane diol, the second is 1,3-propane diol, and the third is 1,2,3-propane triol. The first and third molecules are very important. They are only called by their common names, ethylene glycol and glycerol, by working chemists. Finally, let's talk about the IUPAC nomenclature of ethers. The OR group of ethers, which is called an alkoxy group, has very low priority, so it never defines a parent. It's always a substituent. In strictly systematic IUPAC nomenclature, ethers are named as alkanes with alkoxy substituents on them. The smaller side of the ether is an alkoxy substituent on the larger side. Alkoxy groups are alkyl groups with an added oxygen. The names are derived by changing the YL ending of the corresponding alkyl group to oxy. So, for instance, the ethyl group becomes an ethoxy group. Pause and try these sample problems. Give these molecules systematic IUPAC names. In the first molecule, the smaller half of the ether with 2 carbons is an ethoxy substituent. The parent alkane is the bigger side with 5 carbons, which is a pentane. Give the ethoxy substituent the lowest possible number on the parent chain. This molecule is 2-ethoxypentane. The next molecule must be an alcohol parent, since alcohols are of much higher priority than ethers. This is an ethanol with a methoxy substituent at the 2 position. Finally, the last molecule is simply a benzene with 2 ethoxy substituents at the 1 and 3 positions. So this is a 1,3-diethoxybenzene. Many simple ethers are primarily or exclusively called by their common names. The names are derived by listing the attached alkyl groups in alphabetical order before the word ether. Notice these are all separate words. The first molecule is tert-butyl ethyl ether. The B of tert-butyl beats the E of ethyl. The second molecule is benzyl methyl ether, and the last molecule is diethyl ether. When someone refers to a molecule simply as ether, this is the molecule they mean. It is a very common solvent. Cyclic ethers are important to know. In IUPAC systematic nomenclature, the prefix oxa is added to the name of the corresponding alkane with the same number of atoms. The 3-membered ring cyclic ether is oxacyclopropane, the 4-membered is oxacyclobutane, and the 5-membered is oxacyclopentane. In common nomenclature, it is important to note that the simple 3-membered cyclic ether is almost always called ethylene oxide, but can sometimes be called oxarane. The 5-membered ring cyclic ether is always called tetrahydrofuran. We won't discuss where this name comes from. It's a very common solvent. If you're using my book, I encourage you to do the extra test your knowledge problems for this topic, so you can be sure you really understand it. All the answers are at the back. This video is closely based on my first semester organic chemistry self-help book. The book is organized into standalone topics so you can quickly teach yourself a few troublesome topics. It's also logical and organized from beginning to end, so you can easily learn the whole semester if you need to. My self-help book is particularly valuable in difficult learning situations, but you can also use it to get an edge. If you want to learn more about my books and videos, how to get the books, or my future projects, go to rescueedu.com.